All right, let's dive in. We're looking at a bunch of amazing research that basically gives us a sneak peek into the future of AI. It comes from the Conference on Language Modeling, or COLM 2025. And here's the big takeaway right up front. The whole bigger is better era? Yeah, that's pretty much over. For the longest time, the playbook in AI was just simple. You wanted a smarter model, you threw more data at it, you threw more computer power at it, you just made it bigger. That's what everyone called the scaling laws. But what this new research is telling us is that we're hitting a wall, a big one. It's getting way too expensive, and believe it or not, we're actually starting to run out of good data to train on. So, what this really means is we're at the start of a totally new era. I love this way of thinking about it. AI is basically leaving its childhood behind. It can't just keep getting bigger anymore. Now it has to get smarter. It has to get more efficient, more, sophisticated. And look, this isn't just some cute metaphor. The scaling laws are hitting a very, very real wall. The costs are just astronomical. And researchers are seriously talking about something called the data wall. That's the point where we basically run out of quality text on the internet to feed these things. So the real story here is this massive shift in thinking. The entire field is moving on from that old brute force approach. Just make it bigger. Instead, we're heading towards a new way of doing things that's all about efficiency, actual reasoning, and being way, way smarter about the data we use. So let's talk about the first adult skill that AI is really starting to master: efficiency. This is all about learning to do more with less. It's like AI is finally learning how to budget its own resources. Okay, so one of the biggest resource hogs in these models is this thing called the KV cache. The easiest way to think about it is like the AI's short-term or working memory. When you're having a long back and forth chat with a model, this memory just grows and grows and grows, and it becomes this huge bottleneck. But now, there's a really clever solution called Pyramid KV. Researchers figured out that as information moves through an AI model, it acts like a funnel. In the early layers, the AI's attention is looking at everything. It's really broad. But as it gets deeper into its own thought process, it starts to narrow its focus down to just a few really critical points. And get this, by designing a cache that's shaped like that funnel, Pyramid KV gets the exact same performance as a full cache model while using only 12% of the memory. That is an insane 88% reduction. It suddenly makes having really long, complex conversations with an AI way more practical. But being efficient, that's just one piece of the puzzle. The next big step in AI's journey to adulthood is all about developing real cognitive skills. We're talking about moving beyond just memorizing patterns and into the world of actual, honest-to-goodness reasoning. Now, one of the coolest papers I read had this amazing title, "Don't Lie to Your Friends," and it outlined a totally new way to train AI. Instead of just one AI, they created a whole team of them. But here's the twist. The team only got a reward if they collectively succeeded. This totally changed the game. It forced the AIs to develop what's called meta-knowledge. Basically, they learn what they're good at, what they're bad at, and when they need to trust a teammate to get the job done. And it turns out, for an AI to get better at reasoning, it kind of needs to develop good habits, just like people do. Researchers have zeroed in on 4 key behaviors: verification, which is basically checking its own work; backtracking, so it can go back and fix its own mistakes; sub-goal setting, which is breaking down big problems into smaller pieces; and backward chaining, which means starting from the goal and working backward. It's the AIs that can do this stuff that can actually learn and get better on their own. And this leads to another huge shift in perspective. The whole field is realizing that it's not enough to just give an AI a cookie for spitting out the right answer. If you want to build an AI that can actually reason, you have to look at the entire problem-solving process. Because, let's be honest, a right answer that comes from bad logic, that's just a house of cards waiting to fall over. So all this talk about process leads us straight to the third big pillar of this new age: data. We are moving away from just feeding AI this junk food diet of, whatever we can scrape off the internet, and we're moving towards carefully engineering a nutritional plan for learning. So let me ask you, what do you think is the best kind of data to train an AI on? For a really long time, everyone just assumed it was simple, easy to read text. Like kids' stories. Makes sense, right? It's easy for us to understand. Well, it turns out that's totally wrong. Some really mind-blowing research has found that what makes data easy for an AI to learn from is completely different from what makes it easy for a human to read. The secret sauce is actually statistical simplicity, data that's really predictable and doesn't have a ton of different ways of saying the same thing. In other words, the simpler and more repetitive the language, the better the AI learns. And honestly, this quote from the paper just nails it. It's a powerful caution against anthropomorphizing the learning processes of LMs. Basically, it's a huge warning sign telling us to stop assuming these models learn like we do. We've got to stop thinking about what's easy for us and start building data based on what actually works for them. Okay, so when you start putting these three big ideas together, this new efficiency, the steeper cognition, and this super smart data engineering, you start to see the outline of a totally new kind of AI, a more mature, a much deeper AI. And that has some really profound implications, especially for things like safety and alignment. This gets us to a major evolution in how we think about making AI safe. The old way of doing things was kind of like behavioral therapy. You'd reward a good output, punish a bad one, but you never really looked inside the AI's black box. But the new approach, it's more like neurosurgery. Researchers are now figuring out how to go inside the model and surgically tweak the internal pathways that cause problems like bias in the first place. And now, this is not science fiction. One study actually identified a specific race subspace inside a model's brain, if you will, a part of its internal process related to the concept of race. And by operating directly on that one little spot, they were able to slash racial bias in its outputs by up to 57%. That is a groundbreaking proof of concept. But as AI gets deeper and more complex, we're also discovering some weird new challenges. Take this, for example. You're looking at the word Arial, but it's written in the Times New Roman font. Now, when you show this to a really powerful multimodal AI and ask it, hey, what font is this? It often gets confused and says Arial. Researchers are calling this the multimodal Stroop effect. And it's more than just a funny little quirk. It's a perfect metaphor for a core weakness in today's AI. They really struggle when they get conflicting signals between what they see and what they read. And solving that puzzle is one of the biggest challenges to building an AI that can truly understand our messy, complex, multimodal world. So to bring it all home, we're really watching a fundamental shift in how AI is being built. We are going from scaling up to deepening down. We're moving from just matching patterns to designing real cognitive architectures, from just mining data to carefully engineering it, and from simple behavioral therapy to this new science of what you could call applied interpretility. You know, as AI finally starts to grow up, it's clear this isn't just about it getting more powerful. It's becoming something fundamentally new, something different. And that leaves us with the one question that's going to define the next decade of this field. It's no longer just how big can we build it. The real question now is, how deep can it think?